as I said, we're here multi-threading with web workers. Juan, are you ready to do this? I'm ready. Let's do it, brother. Have a great time.
Thank you. All right. So good afternoon, folks. Today's talk is going to be multi-threading with web workers. So the idea, the intention of the talk for someone of you who are already more experienced front-end developers is going to be refresher on some JavaScript core concepts. For someone of you who may come from a Java background, this is going to be one of the concepts that I think are core when understanding JavaScript. By the end of the session, you will be able to understand how JavaScript handles concurrency, code multi-thread operations using web workers, and refresh on concepts on the JavaScript runtime, such as the event loop. We're also going to see some examples using promises, and identify best cases for each pattern. So hello, I'm Juan. I'm currently a support engineer at Audible, Mexico. You can find me on Slack as JP Ortiz. So the agenda for this talk is going to be, first we're going to see some overview of how this JavaScript handles concurrency. We're going to see the two approaches. One is with the traditional single thread, handle a synchronous operation with promises. Then we're going to see the parallel version using threads with web workers. We are going to have an overview of the JavaScript event loop. And we're going to see some examples with the web worker API. Then we're going to see some demo and use cases, and then we're going to wrap up the talk. So single thread versus multi-thread. This is one of the concepts, and there are concepts from computer science that I found particular complex, like what is the difference between concurrency and parallel operation? Does it mean the same? And in JavaScript, this is particular interesting. So I found a phrase on the internet in one of the talks that I think explains the concept pretty well. Parallelism is about doing a lot of things at once, and concurrency, it's about dealing with a lot of things at once. So it's not similar. JavaScript achieves concurrency with just one single thread. So both concepts help us handle multiple tasks, but one is about structure, and the other one, it's about execution. So how does JavaScript achieves to handle multiple operations at the same time without blocking his single-threaded nature? JavaScript is an event-driven system, and what it uses to handle operations that may have some delay or we have to wait, it uses the event loop. So this is an overview and a diagram of how JavaScript runtime works. The runtime consists of different parts. We have some micro-task operations who handle operations like the then. We have the micro-task queue who handle set intervals, set timeouts, and while these operations are executed, they're going to the call stack, who also has the heap, but to keep it simple, it sends the operations to a call stack that is last in, first out stack. So the event loop is in charge of sending the operations into the call stack to avoid blocking the main thread. And in this example, we're seeing a promise, who is a good pattern for developing asynchronous operations. So traditionally, when we deal with operations that might require some time in order to execute, promises is the way to go. It's traditional how we can achieve asynchronous operations. one of the characteristics of promises is that promises can be re-entered and maintain the context. And this is particularly useful when we're doing like HTTP calls. Here's an example of how the promises behaves in the event loop. There's a couple part of the promise. We can see that we're mocking an expensive operation with a timeout. It's get a 2 seconds delay. And a promise is either success. And if that's success, we communicate that with the resolve method. And if the promise fails, we got into the reject. In either case, both options go to the call stack. And that's the way the JavaScript handles operations with just one thread. So we have a couple limitations of things that JavaScript is not like our first choice when doing some operations. For example, this is not optimal when writing or reading files into the directory or even doing operations in the database. JavaScript with Node.js usually relies on its environment API, such as the browser or Node.js, in order to make this functionality. With the single thread, if we are not aware or cautious about the memory, we can end up in scenarios like blocking the main thread. That's having like a UI freeze. So this may be bad when designing good user experience for our users. We're also limited by the time by taking advantage of using multiple cores and processors in our application. So that's where having parallel operations with web workers can help us. So what's a web worker? Basically, a web worker can help us create different threads inside the browser. Every worker has its own execution context, execution event handler. We're going to see an example. I'm going to start by first declaring a web worker. We're going to see how this is done. In just a script file, in the example, this is script.js, we can see the first 3 elements of the web worker. One, it's we're initializing the web worker. This is the first line you can see here. We're also sending some information using the post message method. And we also have an event listener to deal with the response after we finish doing that expensive operation. And in this example, we actually have the code for the worker. Here we can see 2 elements. One, it's mocking, obviously, the expensive operation with a data.now that's going to mock a 5 seconds delay. But we also have the onMessage function that's going to receive the data that we pass from the main thread into our worker. And you may going to start asking questions about the correct shape or pattern that we should use in that case, and we're going to see that in the next slides. There's a couple things when working with web workers consideration that we may have. In the web worker, we have access to some environments APIs, such as access the console, the WebSocket API, but we don't have access to other elements like interacting with the DOM nodes. So might not be our best options when interacting with the UI of the browser. They run in an isolated environment, as I explained before, so we should be very careful when sending information into even one thread to another, and even when communicated to the main thread of the application. For that, we're going to see the method in the worker. It's called postMessage. PostMessage, it's going to help us send the information back to the main thread after we finish our expensive computation or operation that we're doing. And for this, I have just a very simple example, and this is just to illustrate how the postMessage method works. In this, after we finish our calculation, we have the result, and we send back the result through the postMessage method into our script.js file that in this case is going to be our main thread. This is the example on the script.js file when receiving that information. For here, we can see that we have a listener call, and this is also part of the worker API called onMessage. And onMessage is in charge of receiving that information, and then we can do what we want to do with that information. So you may start asking the question, like, what's a good pattern when sending that information? Because we can be in the case of our working dealing with different methods, different functionality, and we can just simply send like a start as the parameter in the web worker pulse message method, but that's not a good practice. So there's two communication patterns that we're going to see when sending that information into the web workers. The RPC, the remote procedure call pattern, and that's basically giving our JSON, basically putting as a parameter in a JSON structured format the function that we're trying to declare. So with the RPC, we serialize our function with the arguments and send that to our remote destination. So this is a good example. When we're defining the method, we're defining the parameters, and then we use that to send that into the information using the pulse message. Another pattern that we can use is, and by default, we can choose JSON because JavaScript by default already supports the JSON RPC standard. The other pattern is use a dispatcher pattern. This is an example in the script file. As the JSON format, you can see we're sending which type of operation we're doing, what's the value, what are the arguments, and in the next slide, we see it's kind of a switch. If someone have used Redux before, that's the pattern that Redux uses. So this is another way that we can send that information to communicate between information between workers. Another important method of the worker API is the terminated function. This is something interesting. Unlike promises, promises can be stopped, but workers can be stopped. So in order, for example, we can have a separate button called stop expensive operation, and we can use the terminate method in order to stop executing the thread. We can also check if our browser, most of the browsers currently support the worker operations, but like for a sanity check, it's a good practice to check if the worker exists in the context of our window API. And this is an example of how we can check it. And in order to illustrate what web workers can do and to illustrate how we can block the main thread of application, I have created a demo. You can find the package on the repo from code.amazon. It's called WebDevCon 2024 Web Worker Demo. It's a simple file. In there, we have 4 files. One, it's an index.html. It's going to contain 2 buttons, one to make some background change, and the other to emulate a call of an expensive operation. Then we're going to have the script.js, where we are going to put the listeners for the buttons and the definition for our worker. We also have the worker.js file, who contains the logic of our expensive operation and also sends back the information into the script file. And the main.js is because we need a browser in order to launch the web worker, because by security, Chrome wouldn't let us run the workers like without a browser. This is the example without using the workers. In this example, just if you clone the repo, it's going to be basic change background color. But the interesting part here is that the change background stopped working after we start the expensive operation. And that's what I mean by blocking the UI in this scenario. So we're going to try to fix this using web workers. For this, like I mentioned, we have the index.html file. Pretty easy. We have just 2 buttons. We have here we're importing the script.js file, and this is the example of combining the different API. Here we have 2 listeners. One is for changing the background color, and the other is for actually interacting and starting the web worker. In the worker.js, that's the thread that's creating, we have the onMessage function. We start the expensive operation. We're mocking a 5-second delay in the operation. And after the operation is complete, we send back that information using the post message. And in this example, it's just an alert, like expensive operation has finished executing. And after that, if you run the demo, we are able to start the expensive operation, but still using the change event functionality in our application. We can also natively debug in our existing browsers, such as Chrome, with the developer tools. Here we can pause, put breaking points, and see how many threads our service is consuming. This is the example for the service that I mentioned using Chrome. And as a wrap-up, there are some limitations with the web workers. Like I mentioned at the beginning, it is not a good idea to handle DOM operations in the web worker. Also, parallel programming may not be the best solution for every case. If you start working with different threads, we may start entering with race condition and deadlocks. So let's be conscious about when using parallel programming, it's a good option for our application. But we can also see some use cases. If we're planning to do in the servers, in the front end part of our application, expensive operation tasks like image creation, video operation, or even encryption operations, that web workers could be a good use case for this. Also, in a technique, ray tracing technique is a rendering technique for generating image. This could be also a good example while using the web workers in our application. And I saw some really good examples of doing the computational part of our UI in different threads, and then sending back that information back into our UI information. I remember one example that one of my friends sent, and he was creating an animation. He was creating a canvas. It was basically the matrix letters when they fall down. But in order to make that computation, he had to calculate the letter each time, the position, the shadow, in order to make the transition and fade in and fade off animation for the canvas. And he did it in two ways. One is just using the computation inside the JavaScript file, and then after applying the workers, the animation was a lot smooth. So there are some cases where we can leverage the computational part and just get that information and put it into our main application. So this was an overview of the web workers. I also shared the demo, and hope you like it. So thank you.
Fantastic job, Juan.